This will be our last video for section 7.1, and what we're going to try to do is apply our function concept to applications. So the first application is I'm giving the function, I'm going to call it c of x, because we're comparing cost to my units. So if I let my units be x and my cost be c, we're basically saying my cost depends on the unit x. So c of x. So it's a nice visual graph, so we can go and find some values for it. So what is c of 40? Well, again, the input is 40, and we're basically asked to find the output. So looking at my graph, when I have x equal to 40, it looks like the corresponding output is 400. Okay, and maybe that's dollars or something like that. Maybe I should put dollars. All right, so 40 units costs us $400 to make based off of what I'm seeing in my graph. C of 10, again, translating that, x is 10, and we're trying to find the output, c of 10. What is the output of the function c when you let x equal to 10? So I'll go to my graph. Here's x equals to 10, and based off of this graph, giving a rough estimate, I'd say it's right around $250. Okay, so again, we're continuing to use our function notation, input, find the output, and in this case, we're using a graph to find those values. C of x equals 200. Well, be careful. X is not 200, right? C of x is. So this is saying y is 200. So you essentially have to find what input can I put into the c function to create that output. Again, going to the graph, I can see 200 is right here. There's already a data point, and so it looks like x is equal to 0. All right, or functionally c of 0 equals 200. All right, c of x equals to 350. Again, be very careful. We're not saying x equals to 350. We're saying y equals to 350. So I'll go to my grid and just kind of best I can. And I don't know about you guys, but it looks like x equals 30. Or c of 30 equals $350. So using function notation in an application, in this case, a cost application. In the next one, more of a word problem. It says we have a profit function for algebra concept is given by the function p of x, right, equals -1/2 x minus 20 squared plus 400. X is the number of textbooks they sold, and p of x is the profit in dollars. So there's the meaning. So x represents the number of textbooks. P of x, remember that's just y, is representing the amount of profit they made for the x amount of textbooks. So how do we find p of 0? Well, this is basically telling me if that I have x equal to 0, so if I have no textbooks, what will my profit be? So we basically just plug in that value. All right, and I think this is -20 squared, I believe, is 400. Right? -1/2 of 400 is -200. And so they're going to earn a profit of $200. So if there's no textbooks, they're actually earning a profit. So maybe they have some advertising things they're getting money for, or whatever the case might be. But 0 textbooks creates a profit of $200 according to this model. All right, and again, we're just using the function notation. Next one, p of 20. Well, again, the way the notation is, x is 20. We're trying to find the profit when I have 20 textbooks. So how do we do that? We simply, let me come here. We simply replace the x with 20. 20 take away 20 is 0. -1/2 times 0 is 0, and we end up with 400. So when we have 20 textbooks, we will have a profit of $400. Of course, now the question is where do I maximize my profit, right? So from 0 to 20, obviously I want to produce 20 textbooks to get that. I'd rather have $400 than $200, but we don't know. Is there something better? Who knows, right? That's something we'll investigate in another class. Last but not least, p of x equals 350. All right, again, be very careful here, right? X is not 350. P of X is, right? So we're basically knowing what our output is. So what amount of textbooks, what input creates an output of 350? So coming to my function, we are basically solving this equation. All right, so that's what we're basically doing at this juncture. What is our result of this equation? So start solving for X. The first thing I would do is subtract 400 from both sides. All right, that's going to give us negative 50 equals negative 1/2 X minus 20 squared. Let's get rid of this fraction, so I'll multiply both sides by negative 2. Right, that's going to give us 100 on this side. That'll cancel out, leaving us with X minus 20 squared. All right, so here's what we know right now. Based off of what you guys have learned earlier in chapter 5 and 4 and all that stuff, we probably expand this out and get a polynomial and then factor it. But in chapter 10, what we're going to learn is the square root property. So I'm actually going to take the square root of both sides. When I do that, I actually introduce a plus minus to the problem. More on that later. Just kind of follow my lead. So we're going to take a square root of both sides. So this side becomes plus or minus 10, right? Because the square root of 100 is 10. And on this side, the square root and the square basically undo each other. So we're left with X minus 20. So that's the square root property. There's your first look at it, possibly. We're going to do a lot of it in chapter 10. And I thought I'd sneak it at you guys here at the tail end of chapter 7. And so we're going to add 20 to both sides. Oh, by the way, we get two different answers, right? My X minus 20 equals 10, or X minus 20 equals negative 10. If I add 20 to both sides, right, over here we get X equals 30, and right here we get X equals 10. So what this is telling me, according to this model, there's two different number of textbooks that are going to create an output of 350. 10 textbooks will create 350, or 30 textbooks will create 350. And that should be a surprise because this is a parabola opening down, and so there should be two values creating the same y value. All right, and so that's what the math says. Hopefully we're getting very good at understanding, was I given an input and I'm asked to find the output, or was I given an output and asked to find the input? So reading a graph, doing an evaluation, solving an equation, reading a table, is pretty much what it comes down to. So there's your function notation and function relations, domain and range, on to bigger and better things in the next chapter.